couple people have looked, okay. A couple people did realize that I posted an extra credit assignment on the class website on Friday. So, so a lot of you did, quite a few students did it. I normally will always send out an email. Email is not working still, so I will do it again. I will extend that extra credit assignment. So feel free to look at the class website. Motivation to figure out where the class website is in Student View. Okay, I do post stuff there. If you're ever absent, you can go and watch the notes and take notes. And I'm gonna try. I can't promise that I'll be able to, but I am gonna try to take a photo of the problems out of the book and post that as well. I will do my best. It takes the more I do it, longer it takes. But okay. Here we are. So a quick review of perimeter area and volume. Please, as you're doing class practice number 3 today, make sure that you read the directions. I have sort of consolidated the notes to take as little time as possible. So we're doing multiple things, and you don't have to do this much, okay? Most of the time. All right, so in notes, please make sure you're writing the direction. Example 1 is a must. Write down that example 1. Find the perimeter and area, and maybe page 914. So whenever there's something that has lots of formulas, I will make note of the page in the textbook. It's probably a really good idea to go ahead and take a photo of that page just so you have a record of formulas that you can look up if you need to for like a test or whatever, if you're studying for a test. So definitely make sure you've got example 1 and then probably find perimeter and area. And maybe page 914. Make sure you get that example 1 in there good so that I can grade your notes efficiently, easily. I see lots of people bringing out their colors. You know, I use colors a lot. Great. When you're doing your homework today, I had a lot of students second period, like just write answers, and that's not good enough. Some of the problems are really, really easy. So either just show me the math, 6 plus 6 plus 12 is 24, or a picture is worth 1,000 words. If you just make a quick sketch of the picture and then put an answer, sure, that's fine. A lot of this stuff you are smart enough to just do in your head. So draw me a picture or show me a little bit of math. Show me some work. Okay. All right, so here we go. This first one, letter A, this is what happens when I condense things. It just doesn't quite work out. On this first letter A here, we're only going to find the area. So we have a parallelogram with a base of 7 inches and a height of 4 inches. So a parallelogram has two sets of parallel sides. So these are parallel and these sides are parallel. Do you know those little parallel arrow markings? Have you seen those before? Your books usually color code them red. But those are parallel sides. And then they say it has a base of 7 inches. Where does that 7 inches go? It's not a trick question. On the base, right? Okay. So 7 inches goes on the bottom. My big question is, what does it mean when they give you information about height? What is height? It's very specific. So that base is 7. That assumes that the top is also 7. Where is the 4 supposed to be? Sir. Yes, yeah, it's perpendicular. Height is defined as perpendicular to the base. So it's always perpendicular. So this is the height, and in this case, the height is 4 inches. Over here, this might be called a slant height, all right? But we want to make sure that we know it's just height is perpendicular. Does anyone know the formula for the area of a parallelogram? It's just base times height. Okay, it is just base times height. The way you think about this is in a, what's the formula for the area of a rectangle? Base times height, right? Base times height. Okay. Guys gotta know this stuff. This is like ACT 101 right here. It's on the ACT that you have to know all these formulas. You can imagine if I were to take this triangle off and sort of just slide it over here, it would sort of fill in this space, and really all it does is morph into a rectangle. And that's why the formula is the same, okay? As long as we have a perpendicular height. So the base is 7 inches and the height is 4 inches. And so what is the area of this parallelogram? 28. What are the units? Inches squared. Very good, because inches times inches is inches squared. Okay. Excellent. Now, letter B is much harder. And I'm throwing in a whole lot of information here. What is this shape? What is this shape called? Trapezoid. Good. Trapezoid. All right, it is a trapezoid. And the first thing we're going to find is the perimeter. What is perimeter? The length of all of the sides, the outside. Perimeter, peri means around. So, and meter would be like length. So the around length, to go all the way around the figure, we would simply do what? Let's say all of these are inches. Add them up, sure. So all of these are inches, so we would just say 5 plus 4 plus 5 plus 10, and what would that give us? 24. What are the units on that? Just inches. These are length units, and length units are just inches, feet, meters. Area units get the squared, okay? Now, we also want to find the area of this figure. The area of a trapezoid. Does anyone know? This is why I did this one, because this is a formula I don't really know if you remember. Anybody know the formula for area of a trapezoid? You got a guess?
It's base times height divided by 2.
That's triangle. So you're close. So whenever you don't know, right? So one, method you could do is to say, hey, a trapezoid, especially one like this. This one is isosceles. Isosceles meaning these two legs are the same. You can always subdivide it into figures you do know the area of, right? So if I wanted to find the area of this trapezoid, I could find the area of the rectangle, add the area of this triangle, and add the area of the right triangle. So that is an option, okay? I do want to just give you the formula. It is 1/2 base 1 plus base 2 times height. 1/2 base 1 plus base 2 times height, okay? It's the sum of the bases split in half. The average of the bases times height, okay? Now, here is the question, though. I know, what are base 1 and base 2? 4 and 10. And it doesn't matter if you put the 4 here or the 4 over here. It doesn't really matter. 4 and 10. 10 and 4. Doesn't matter. Same thing, okay? But my question is, what's the height? That's the tricky part on this question. You don't have any quite this hard on your homework, but I wanted to throw this in there because it's useful. Where is the height represented in my picture? Yeah, it's my thing that I dropped down. This right here represents the height perpendicular to the bases. It's perpendicular to both bases. And so we need to find that height because he didn't give it to me. So now I have this right triangle. I know up here we have a base of 4. What's this piece right here? Also 4, isn't it? Sure. Yeah? Yeah? Okay. So then can we figure out what this length is and what this little length is? What would those be? 3 and 3. How do you know those are 3 and 3? Yeah, because there's 6 left over. We used up 4. We had 10. So there's a difference of 6, and these should be the same size because it's a nice isosceles trapezoid. All right, so 3 plus 4 is 7, plus 3 gets our total length of 10. So very good. Now I have this right triangle that has a base of 3. I need to find the height, and it has this long side. What is that number 5 called? What is its formal name? The long side, right? Hypotenuse, very good. Okay, so that is the hypotenuse. What can we do to figure out h? A squared plus, I heard it, yep, very good. Pythagorean theorem, a squared plus b squared equals c squared. The Pythagorean theorem, in the Pythagorean theorem, what is the c? What does c, the longest side, or also known as hypotenuse, very, very important. So c is always the hypotenuse. And so I'm going to make sure I put that in first. That is the most important thing. The hypotenuse is always opposite that right angle. So it is a 5. It's being squared. And what can we put in for the a and the b? 3 and the h, sure. And it doesn't matter which goes where. Just a leg squared plus a leg squared. So 3 squared plus h squared. Good, good, good. What is 3 squared? 9. So 9 plus h squared equals, what is 5 squared? 25, good. And how do we solve for h? Subtract 9, good. So we have h squared equals 25 minus 9 is 16. How do we get h by itself? Square root. So we get h equals 4. How many of you remember doing this? Good. Okay, so now we know that our height is also, our height is also 4 inches. And now I can plug that 4 in for the height here. It's just a coincidence that it matches. Okay. So we have half of our base 1 plus base 2, 4 plus 10, and then times our height that we found that was 4 inches tall. So I have half of the sum, so half of 14 times 4. What is half of 14? 7 times 4 is 28. And what are the units? Inches squared. Very good, inches squared. I said what's half of 14 and you told me 7, and that's good. Do you have to do half of 4 as well? No, it's not distributing. There's no plus in between. Okay. So you just multiply from left to right. All right? Questions on that? Was that like a really good review or what? It was a lot, right? Yeah. Now, what I want to point out is this triangle, a right triangle that is a 3, 4, 5 triangle. This is called a Pythagorean triple. How many of you have heard that before? Okay, a few of you. Pythagorean triples are really, really important, and they're used all the time on the ACT test. Does anyone know any other Pythagorean triples? Yes.
This might be very, very wrong, but 5, 7, 12? Or something like that?
It's 5,
12, 13.
5, 12, 13. That's it. Very good. 5, 12, 13. That's another Pythagorean triple. It's always going to form a right triangle. And there's another one, 7, 24, 25, also forms a right triangle. All right. And then, of course, you can take these Pythagorean triples and you can double them or triple them. So you can multiply 3, 4, 5. You can multiply everything and create a new Pythagorean triple. So if you multiply everything here by 2, what would that turn into? 6, 8, 10. 6, 8, 10 is also Pythagorean triple. Okay? So you can multiply by any number and create a new Pythagorean triple. And they do this all the time on ACT tests. So you don't have to do all of this work if you know your triples. Okay? You just know them. So 3, 4, 5, and 6, 8, 10 are really common ones. 5, 12, 13 is the next most common. All right, I have one more. Oh, shorter page, hold on. Oh, no, I missed a page. That's so good. All right, I'll wing it. All right, example 2 is, do it on the back. Example 2, find the surface area and volume of the prism or cylinder. See page 915. Find the surface area and volume of the prism or cylinder. So again, I'm combining two things. Now when you do your work today, this is all separated. There's like a section, just find the surface area. And then there's a section, just find the volume. So make sure you don't do more work than you need to. So the first one we're going to do is a triangular base prism. Triangular base prism that I didn't draw because drawing these figures takes a long time. So I'm going to draw this. A prism is has two bases, a top and a bottom, and it's in this shape. So in this case, we have a triangle. So I'm going to go ahead and draw that triangle. Putting the accent on the wrong syllable. Interesting. So I'm going to call that my top because I sort of ran out of room. And then I'm going to draw a matching one just below it. I'm going to try and keep my lines sort of all parallel. Let's do that. All right, so this is a right triangle, the bottom and the top. A prism always has some sort of shape on the bottom and top. That's the base. And then all the lateral sides are connected by rectangles. So all I'm going to do, once I have my two bases drawn, is just connect them with lines. And there is my three-dimensional figure. That is a prism. So just by drawing those pink lines down to connect each vertice, those are rectangular shapes. So a prism is defined as any shape base, whether it's a circle or a polygon, or in this case triangles, connected by rectangles. All right. I'm going to go ahead and give some labels here. I'm going to say that this base of the triangle is 6 inches, and the height of the triangle here is 8 inches. And the height of the prism, this full height from base to base, that height is 5 inches, the height of the prism. All right, the first thing we want to do is we want to find the surface area. What is surface area? Yeah.
Every side and then
The area of every single side of the figure added up. So I want to look, this prism has how many faces? 5 faces. Sure, we've got the 3 pink rectangles and then the top and the bottom. So there are 5 faces. So if we want to find the surface area, we want to find the area of all 5 faces and just add them up. And that's what surface area means. So first of all, I have a couple of triangles. How many of these triangles do I have? 2. Sure, top and a bottom. So I'm going to do 2 times the area of the triangle. And my triangle has a base of 6 inches and a height of 8 inches. How do I find the area of a triangle? What's the formula for area of a triangle? 1/2 base times height. Very good. 1/2 base times height. So in this case, we would do 1/2 base of 6 and a height of 8. Oh, listen. Okay. And then we have 3 other faces that are all rectangular in shape. So I'm going to do this first one. We want to add to that this pink face. What are the dimensions on that pink face? 6 and 8, sure. Base of 6. Oh, not 8. What is this pink height here? 5. Yeah, it's the same height as this one. So that's a 5. And so we want to find the area of that, which would just be base times height. Our base is 6 and our height is 5. Then we have this green face here on this side, also a rectangle, harder to see. What are its dimensions? 8 and 5. Yeah, the base is 8 because it runs all along this edge of this lower triangle, and then it has that height of 5 as well. So again, base times height is going to be 8 times 5. And then we have our last face, which is this blue one over here. This really, oh, did I just run out of blue? Let's switch to purple. All right, so here, this face all along here. So this is a very, very long side. What's its height? 5. Good. What's its base all along here? Not 14. 10. 10, it's 10. So how could we, if we didn't know, how do we figure out what this length is right here? It's a right triangle. We got a base of 6, we got a base of 8, and we want to know, C, the longest side. Pythagorean theorem again, okay? So once again, 6 squared plus 8 squared equals that hypotenuse squared. What is 6 squared? 36 plus 64. And then what is 36 and 64? 100 and square root. So it turns out to be 10 by the Pythagorean theorem, okay? Or the 3, 4, 5 times 2. 3, 4, 5 Pythagorean triple times 2 gives you a 6, 8, 10. So this is 10 units long, 10 times 5. Now my question is, who was your geometry teacher? Holbrook. I'm always curious. All right, let me go ahead and multiply some of these together and figure out the total surface area. What's half of 2? 1. So 6 times 8 is 48. 6 times 5, 30. 8 times 5, 40, and 50. 30, 40, and 50, 90, what is that? 120? All right, so 120 plus 48, 168. What are the units? Inches, just inches. Oh, inches squared, rather, it's area. So there's our surface area. All right, surface area I think is the hardest thing to find. Volume is much easier. We're going to go ahead and find the volume. Last thing here. How do you find the volume of any prism? Yeah.
Base, height, your width, and then the height.
Good. So we do capital B times H works all the time for volume of some kind of prism, okay? Capital B is the area of the base times h, which is the height of your prism, okay? The area of the base in this case is what shape? What shape is the base? We got two bases. What shape are the bases? Triangles, okay? So in this case, they are right triangles. And how do we find the area of a triangle? 1/2 base times height. And then the height of our figure happens to be 5. That's the height of our prism. So here the area of the base, 1/2, the base of the triangle is 6 and the height of the triangle is 8. 1/2, 6 times 8 times that height of 5. What do you want to do? A couple ways we can do this. 24 times 5. So how'd you get 24? Yeah, 6 times 8 is 48. And so then instead, what's half of 48? 24. And then 24 times 5 is 120. Very good. And what are the units on volume? Cubed. Very good. When you think about that, 6 inches times 8 inches times 5 inches, inches times inches times inches is inches cubed. All righty. All right. Do you guys have questions for me? There's a lot of geometry right there. That's like 2 weeks of geometry in. Let's see. Yeah, in 20 minutes. 30 minutes. All right. You guys have 25 minutes left to work as much as you can on this assignment. And remember, today you'll get to take a photo and finish it tomorrow during the assembly.
Yeah, I'm already on my way back. Should have asked me.